Nowadays, the question of Arctic exploration and development is one of the key issues in Russia's domestic policy. This territory, rich in natural resources, can become a guarantor of sustainable development and national security of the country in the 21st century. In the Strategy for the Development of the Arctic Zone of the Russian Federation, dated 18 September 2008, the use of the Arctic Zone as a strategic resource base is cited as a primary national interest, ensuring the solution of problems of socio-economic development of the country. It is obvious that the development of the far north is impossible without transport and related infrastructure that would meet the harsh conditions of the Arctic. However, there are a number of problems in this direction.
In terms of transport infrastructure, the Russian Arctic is characterized by two unequal areas in the western and eastern parts. The western sector has a fairly extensive system of roads and railways, with year-round links to land transport of the country and Arctic seaports. In the eastern sector, there are no year-round overland transport routes with access to the national network. As a result, many of Russia's Arctic regions and their populations were in fact subject to transport isolation. The strategic challenges of transport development in the Arctic are as follows: the underdevelopment and poor technical condition of the transport network, high depreciation of the rolling stock, limited availability of transport and logistics services, low efficiency and cost-effectiveness of the transport complex. The most important factor affecting the Arctic transport complex is also climate change. Data in the relevant Roshidromet assessment reports shows that the Arctic over the past 3 decades has been warming faster than the rest of the globe. The shrinking of the Arctic Ocean ice sheet will continue throughout the 21st century, and it will happen so mostly by reducing the area of perennial ice. Global statistics confirm the validity of model calculations and forecasts made by scientists and experts about the accelerating pace and increasing scale of the social and economic consequences of warming. As a result, the period of operation of the so-called winter roads should be significantly reduced, which may in the short term worsen the transport accessibility of the Arctic regions. Accordingly, such an unfavourable outlook is the most important reason for the urgent need to modernise transport infrastructure for the entire Arctic region.
Sustainable development of the Russian Arctic economy requires a fundamentally new transport and infrastructure complex. At the same time, safe and efficient operation of transport is to be possible under harsh Arctic conditions. Today, such technology is already available. It is an efficient and safe transport of the second level, Yunitsky string transport, abbreviated UST.
Flyover implementation of UST transport and infrastructure complexes allows for effective solutions to problems associated with permafrost and snow. For example, lifted above the ground to a height of 10 meters or more, the string rails are permanently self-cleaning from snow and ice by the steel wheels of moving transport. A rail string track, point-wise mounted on pile foundations of open supports, keeps the land untouched, does not violate the established temperature regimes of permafrost, does not obstruct animal migration routes and ground and surface water movement. The foundations of the supports are arranged in a specific manner. In wintertime, they pump cold into the permafrost soils, and in summer, block the heat from entering there. The length of the span in a string rail flyover can be up to 2 kilometers, which allows extensive obstacles such as rivers, bays, lakes, deep swamps to be hurdled without supports through the air. This provides a high level of safety by raising the rolling stock to the second level, where there is no possibility of collision with the moving objects on the ground. The UST string rail transport flyover is resistant to frost down to -60 degrees Celsius and heat up to +60 degrees Celsius. Snow drifts, river overflows, earthquakes, gale force winds, tsunamis and other extreme impacts. The capacity of the UST complex can reach up to 25,000 passengers per rush hour and 100,000 tons of cargo per year, bulk, piece, liquid one. The automatic control system eliminates risk due to human factor and is able to maintain safe operation of the complex in any natural or climatic conditions in Russia and other countries, including in the Arctic, year-round, 24/7. It should be highlighted that such exceptional characteristics of the UST transport and infrastructure solutions are neither hypothesis nor theory, but practice.
The combination of these advantages makes the new mode of transport the most efficient in terms of safety, accessibility, cost-effectiveness, reliability, and environmental friendliness. These advantages will be particularly sought after in Russia's Arctic latitudes. Construction of a light, yet strong string rail flyover in areas with mountains or permafrost costs far less than constructing any of the transport alternatives available on the market, including cable cars, naturally, under comparable construction and operating conditions. The string rail track structure and supports can easily be combined with overhead and cable power lines and communication lines, wired, fiber optic, radio relay, cellular ones.
The UST transport and infrastructure solutions are already implemented and being developed in the Republic of Belarus and the United Arab Emirates, where 6 types of string rail flyovers and 12 types of fundamentally different unimobiles have been built and put into operation, including the high-speed unimobile. Its speed is up to 500 km per hour. The other 4 test complexes and several new 5th-generation unibuses are under construction and assembly.
One of the UST solutions has already been internationally certified in the United Arab Emirates in the city of Sharjah. The U-Sky Tropical Transport and Infrastructure Complex was commissioned in 2021 and certified according to international regulations as a complex comprising string rail flyover, a passenger technology station, tropical rolling stock, automatic control system including a dispatch room, engineering networks and landscaping, including roads. The company developer of UST Yunitsky String Technologies Inc., Minsk City, has received orders for pre-design works for a number of commercial projects in several countries of the world. It should be proudly pointed out that the first, most difficult and significant steps in the implementation of the UST industry-forming technology have been taken in Russia.
The first test site for testing the UST transport and infrastructure solutions was built in the town of Ozhyroy, near Moscow, in 2001. The tests have confirmed the viability of the new transport. During the same period, in the late 1990s and early 2000s, 2 UN habitat projects were successfully implemented in Russia. Number FSRUS 98S01 Sustainable Development of Human Settlements and Improvement of their Communication Structure using String Transport System, and number FSRUS 02S03 Ensuring Sustainable Human Settlements Development and Environmental Protection using String Transportation System. Russia has become a stronghold of the string technology, not only because of its national and cultural background, but because of the need to implement innovative ideas in the field of transport and infrastructure in order to unlock the enormous potential of this largest country in the world.
UST can provide many points of economic, social, geopolitical growth for the Russian Federation, contribute to a substantial improvement in the well-being and quality of life of its citizens, while ensuring the preservation and restoration of our greatest treasure, wildlife. The technical and economic features of UST transport and infrastructure solutions are designed to help improve approaches to urban planning, in the organization of production and logistics chains, in the development of remote and inaccessible territories, where people can comfortably live and work along communication lines, once and for all having saved Russia from such problems as, for example, the northern delivery. That can also greatly increase the mobility of the population and strengthen the country's defense capabilities.
Another important direction is the development of the Northern Seaway as the main shortest route, and also the creation of a chain of offshore ports for the delivery of goods far from the shore. In doing so, the port and shore will connect the UST transport complex with warehouses on land. The main advantages of this system would be as follows. For the mooring of large vessels, it will not be necessary to build quay walls and carry out dredging and shore protection works. No immediate storage of cargo will be required. The string transport will provide full automation of loading and unloading processes, and the remote control of these operations without the need for people to be in potentially hazardous areas.
The problem of industrial waste management is extremely acute in the Arctic zone in enormous quantities accumulated around industrial plants.
How can this problem be solved? First and foremost, through the use of relic solar bioenergy, the waste products of which would be the fertile biohumus. Lignite and oil shale-fired combined heat and power plants will produce living, highly fertile relic biohumus from the combustion of solid fossil fuels, which have the same chemical composition, over 80 chemical elements, macro, ultra, and trace elements, like ancient soil hundreds of millions of years ago.
The quality of such biohumus, as well as its market value, would be higher than that of stodgy turnism, and the food grown on it will be only organic, without the use of chemical fertilizers and pesticides.
Meanwhile, lignite reserves in northern Russia are sufficient to produce over 1 trillion tons of biohumus, with a total market value of over $1,000 trillion.
It would be possible to develop comfortable living conditions around such biovoltaic power plants. Millions of people would be able to live and work here, despite the region's harsh climate. The basic form of settlement in the eco-house Arctic is designed based on innovative approaches to housing construction in northern latitudes.
The housing complex is designed as an independent system to provide everything you need to live: organic food, drinking water, clean air, energy, favorable climate and atmosphere. At the same time, the string transport station, harmoniously integrated into the eco-house, is equipped with a universal power plant, capable of operating on any type of fuel. The design features and technology used will allow the occupants to produce agricultural produce for their own use and export in addition to their main occupation. The accessibility of the settlement, as well as the delivery of residential and production modules to the assembly sites, will be ensured by the UST Transport and Infrastructure Solutions. The implementation of the concept will enable efficient development and development of the Arctic region with high economic efficiency. The attractiveness of the eco-house Arctic will be ensured by more comfortable living conditions in them, as well as transport accessibility with considerable savings on construction and operation of all residential, industrial and transport infrastructure.
Implementation of the mentioned technological solutions as part of the Arctic development programs will ensure the creation of a new transport infrastructure industry, which will be able to function regardless of climatic and weather conditions, will solve the issues of orders for companies involved in a wide range of industries. The development of a year-round transportation infrastructure will not only solve the problem of getting people to travel between the Arctic regions, but it will also create new agglomerations with the increase in their population. Establishing mass production of biohumus from lignite and oil shale will enable the product to be exported around the world, generating profits even higher than those currently enjoyed by oil suppliers, as the need for humus will be much higher than the need for oil. Development and settlement of the currently uninhabited northern territories through the construction of eco-houses Arctic. The use of such technologies will relieve all of the Arctic region's current problems, providing infrastructure, resource, food, transport and energy security, as well as creating favorable living conditions for people in the harsh Arctic climate, which means it will potentially increase the flow of workforce into the region. That will create all the necessary conditions for sustainable development of the northern territories and for their large-scale inclusion in economic supply chains. This could be one of the growth drivers for Russia as a whole in the long term, which will strengthen the country's position on the global stage and will be conducive to improving the quality of life of the population.